Hello and welcome to this webinar on Docker and Windows Server 2016. My name is Michael Frith. I'm a product manager at Docker, and I've spent the last 10 months helping people trying to make this work. So I'm really excited to be here today and to tell you more about how Docker works on Windows Server 2016. My contact info is on this slide, so feel free to tweet at me at Frism or write me an email at michael.frith@docker.com. And we'll also be taking questions later, as Trish just mentioned. Okay. So what happened with the launch of Windows Server 2016 was that Docker and Microsoft have been working for the past 2 years to add containerization to Windows Server, and also to Windows 10 actually, and then on porting the Docker engine to Windows.
They can't hear you. Can you see if they can hear you?
Can you guys hear me all right?
Okay. Thank you. It looks like some people can hear Michael and some people can't. You may just need to adjust your speaker volume if you can't hear Michael.
Okay. Okay. All right, I'm just going to start from the top of this one again. So the situation now where Windows Server has support for containers and where Docker Engine runs on Windows Server is that you can use Docker tools, APIs, and image formats for managing 98% of enterprise workloads. So it used to be that Docker was mostly a Linux technology that you could use to containerize Linux apps. But now, even if you work in a big organization that have heterogeneous workloads that require that you run both Linux and Windows, Docker is kind of a common language and a common set of tools that you can use across your organization to manage all those apps running on both Windows and Linux. And so at Docker, we're really excited. Like, Docker has transformed how developers and operations build, ship, and run apps for the past 3 years on Linux. So we're just incredibly excited to be driving that same transformation and innovation with Microsoft on Windows Server and doing the same for Windows developers and Windows IT pros. And so I want to emphasize right from the beginning that if you get Windows Server 2016 and if you get support from Microsoft, then Windows Server 2016 comes with the Docker commercially supported engine. So that's the variant of the Docker engine that we've been supporting on Linux for the past couple of years. You get that at no extra cost on Windows Server 2016. So if you have a problem with Docker running on Windows Server 2016, you can call Microsoft. They'll try to help you out. And if they can't figure it out, they can escalate to Docker, and we'll sort it out for you. And then the diagram at the bottom just shows how Docker sits on top of both Windows and Linux, giving you a common API, common set of tools for managing both Windows and Linux workloads. And as mentioned, this is something that Docker and Microsoft have been working on for more than 2 years. So we formed a partnership in 2014. And in the context of that partnership, Microsoft went and added containerization primitives to the Windows kernel. And with the launch of Windows Server 2016, that's now live and available on your production systems. So the Windows kernel now has the same kind of containerization primitives that Docker built on Linux. And actually, Microsoft also shipped those containerization primitives in the Windows 10 kernel. So if you have Windows 10 with their anniversary edition update, you can run Docker containers directly on Windows 10. Then in addition to the Windows kernel work, Microsoft and Docker collaborated to port the Docker engine and all the other tools to Windows. So if you go look at the Docker open source project right now at github.com/docker/docker, you'll see that there's a whole bunch of Microsoft employees contributing very actively to the Docker engine. And there's even one of the kind of Docker engine maintainers is also a Microsoft employee, John Howard. So that's pretty cool. Then kind of in parallel to this work on Windows and the Docker engine, we've also worked to make sure that kind of Docker Hub, the Docker registry, and all the other tools that you interact with if you use Docker, that they have that they understand and can use both Linux and Windows images. So on Docker Hub now, there's already a bunch of images for both Linux and Windows. So we maintain Golang, MongoDB images for Windows, and Microsoft also maintains a whole bunch of images for IIS, .NET, Full Framework, .NET Core, SQL Server, and other images, and we're working to expand that. So this is just to give you an idea of kind of the breadth of the collaboration and the scope of what you can do if you're a Microsoft technologist wanting to use Docker. So starting on the left with build, you can, if you're a developer, you can use Docker on your developer machine to build containers with Docker for Windows. The Visual Studio team has built plugins for Visual Studio that let you use Visual Studio to build and debug containers. They have a really neat plugin actually, where when you hit F5 in Visual Studio and like kind of start debugging, Visual Studio will start up your app in Docker containers and then attach the Visual Studio debugger to the process running inside of the container, and you can step through line by line with Visual Studio the code that's running inside of the container. Then we made a Docker Hub multi-arc aware, so you can store Windows-based images on Docker Hub, and that's also where Microsoft is publishing the base images for Windows. I'll get into that later, and a bunch of other images. And finally, you can run your Windows-based containers in production, either on-prem on Windows Server 2016 or on Azure or other clouds that will be getting Windows Server 2016 support. Yeah.
We had a couple of questions. One, does Docker in Windows Server 2016 or 2012, will that work?
No. So fundamentally, the containerization primitives are only available starting in Windows Server 2016, and then also in Windows 10 for kind of development purposes.
And then the other question is, can we play and test things using Docker for Windows or Linux?
Yep. So yeah, I'll get into details on getting started, but yes, if you install the public beta version of Docker for Windows, so Docker for Windows kind of has two channels, as a stable and a beta channel. And in the beta channel, we already set up the Docker engine running natively on Windows 10, so you can use Docker for Windows to develop containers that way. If you don't want to do that, say, for example, you're on Mac OS or an older version of Windows, you can download a trial version that's good for 180 days of Windows Server 2016, and you can just set it up as a normal VM, or you can start a VM on Azure. There's a bunch of different options for trying this stuff out. I'll get into that in detail later. Okay, so just to give you an overview of some of the technical details. So if you're familiar with Docker, you know that like you write Docker files, or you typically, and you can have a from instruction where that defines the base layer, the base layer that the image that you're wanting to build starts from. So when building Linux containers, you can start from scratch, which is kind of like a empty userland file system, or you can start from Debian or Alpine or Ubuntu or any number of other base layers where you kind of get a working Linux distribution to base your container on. On Windows, it's a little bit different. You can choose between two base layers, and I'll demo this in a little bit also, but just to give you an overview. The first choice is called Windows Server Core. And so Windows Server Core is the version of Windows Server that like it doesn't have the full desktop experience, but it's a complete installation of Windows otherwise. So the good thing about that is that really any sort of app that you can make run on Windows Server, you can make that run in a Windows Server core container. So like take IIS or SQL Server, or you can install the full .NET framework, Jenkins, MS Build, like kind of all the classical Windows software runs fine in a Windows Server core container. So the downside to that is that the image is a little bit bulky. So I think the download is a couple of gigabytes, and it's slightly larger when expanded onto the file system. So that sounds like really a downer, but in practice it turns out to be less of a problem because typically what will happen is that like as you build different versions of your containers or multiple different container images, they're all going to be based on that Windows Server core base layer. And because Docker is so good about image layering and image and layer sharing, you only really need that big Windows Server core base layer once. And all of the containers on your machine, be it your development machine or your production system, they're just going to use the same Windows Server core base layer that you get once. So it's not too bad in practice. Then the other option is Nano Server. So Nano Server is a new variant of Windows that Microsoft started shipping with Windows Server 2016, and it's really exciting for two reasons. And the first reason is that it's kind of an example of a minimalist operating system that's in some ways optimized just for running the Docker engine and then running containers on top. So if you go, there's actually a blog post on the Docker blog about this from about a year ago, talking about this notion of minimalist operating systems optimized for running containers. So other examples are CoreOS or maybe Rancher, or if you poked around in Docker for Windows or Docker for Mac, you'll know that we also have a minimalist Linux version in there that we call Moby. And Nano Server is another example of that. So it's a super stripped down version of Windows, which means that you have to update it less frequently. There's less security attack surface area, and it boots faster, and it's just easier to deal with. But there's no GUI, of course. And then so it's great as a host operating system for running containers, but it's also really great as a base layer for your container images. So if you're doing greenfield development, then a Nano Server is a good choice, I think. So because it's so minimal and because they stripped out so much of what used to be Windows, you're a little bit limited in the kind of programs that you can make run inside of there. But IIS runs, for example, and the new version of .NET, .NET Core, has also been ported to run in Nano Server. Okay, so that covered the two kind of base image choices that you have. Then another interesting thing about the Docker implementation on Windows is you also have a choice of isolation. So if you're used to using Docker on Linux, you know that you can lock down running containers with seccomp profiles and in other ways. So think of this kind of isolation choice in the same way. But basically, when starting a container with Docker on Windows, you can choose to run it either as a Windows Server container or as a Hyper-V container. With Windows Server containers, which is on the slide on the left. So the two containers on the left are running as Windows Server containers, and you can see they use the same model as on Linux, where the kernel, the Windows kernel, is shared between the operating system userland processes and the container processes. But the containers, of course, run in an isolated context, so they have their own little isolated file system registry, and the process context is also isolated. So that gets you great density, all the benefits, and fast startup times, and all the benefits you get of containers on Linux. The other mode is Hyper-V containers. And so what the Docker engine does when you start a container with Hyper-V isolation is that actually starts a thin hypervisor and then a very minimal Windows kernel, and then the container image is placed inside of that hypervisor where it then runs. And the benefit of that is at the cost of a little bit of resource overhead. You potentially get better isolation. So if you have kind of regulatory requirements, or maybe you're trying to run a kind of hostile multi-tenant platform, then using Hyper-V isolation might be a good choice for you, because you get that extra layer of protection from the hypervisor at the cost of a little bit more resource overhead. All right, moving on. This is a slide that compares the two architectures on Windows and Linux. So you can see at the bottom, on Linux, Docker makes use of stuff like C groups and namespaces, and then layered file systems to kind of make Docker happen, and to stage manage the operation of containers on Linux. So what Microsoft did to support Docker was they added similar primitives to the Windows kernel: job objects, object namespaces, and then they also built layering on top of NTFS, the Windows file system, and they also made the registry, the Windows registry, also now is kind of layered and isolated. And then Docker engine runs on top, either Windows or Linux, but it's the same code base. It's just operating different, it's just manipulating different operating system primitives, and it exposes the same REST interface on either Windows or Linux that can then be consumed by the Docker CLI, Docker Compose, all the tools that you know and love from running Docker on Linux. And actually, Microsoft very helpfully also went and built something they call a PowerShell for Docker. So if you're a Microsoft technologist and you really like PowerShell, and you're not too thrilled about learning the Docker CLI, then you can use the PowerShell commandlets, and they operate the Docker engine REST API exactly the same as the Docker CLI. So there can be two guys on the same machine, one using the Docker CLI and one using the PowerShell commandlets, and they see the same view of the world, because both of those interfaces operate the same Docker engine REST API. This diagram goes into slightly more detail, comparing Windows Server containers and Hyper-V containers. So you can see on the left are the usual userland running on Windows. Then in the middle, in the middle, there's a Windows Server container running. And you can see it shares the Windows kernel with the other userland processes on that machine, but it's isolated in a container. And then all the way on the right, there's a Docker container running with Hyper-V isolation. So you can see it runs on top of the hypervisor. That's a minimal Windows kernel, and then the container process executes inside of that. And yeah, so if you're a developer, you don't really have to worry about this Windows Server containers versus Hyper-V containers. You can build a container image, and then somebody can go run it as a Windows Server container or Hyper-V container. It'll work as either. So it's just a choice that you have as an operator to isolate container processes more or less. And just to emphasize some of the benefits that you get with Windows Server and Docker, and I'll show this more in the demo, but with containers, because apps, when you package apps up in containers, you package them up in an image where you have both the app and then all the dependencies, the libraries required to run the app. And the neat thing about that, even if you're just a team of developers, is you get rid of the kind of works on my machine problem, where I set up my machine just right with all the libraries and software required to run the app, and then I check in the code and somebody else checks it out and tries to run the app, but they're missing whatever configuration and tweaks I did on my machine to be able to run the app. Docker gets rid of that, because either there's a Docker file recipe that Docker can use to get all the dependencies required to run the app and build a container image, or you just ship the container image, which is a fully built image with all the app's dependencies and the app itself. And you can kind of be confident that will run anywhere, no matter what other software happens to be installed on the server. Yeah, so like if you're on Windows, like with Docker containers, you can easily have two Docker containers running side by side in the same system with completely different versions of the full .NET framework, with different versions of IIS, and with kind of crazy registry settings or mutually incompatible registry settings. And those two containers will not interfere with one another and will not affect the host system executing the containers. So yeah, just makes it much easier to manage dependencies and server setup. It also makes maintaining CI machines way simpler, because if you have a CI machine that runs CI on a bunch of different apps with different dependencies, all that crust can just be inside of the container images and doesn't leak out onto the CI system. And finally, Docker images and Docker application bundles it's just a really great interface between dev and ops. Maybe currently the process of deploying an app is this kind of laborious thing where developers try to convey to operations what are the dependencies required to run a particular app, and then ops tries and goes and sets up those systems. And then later on, a developer changes the app to take on a new dependency and forgets to tell ops about it, so when ops deploys it, the app breaks. With Docker images, because all the dependencies are bundled up, developers can ship the images, or the images can get built in CI and then tested by QA and then deployed by ops, and you can kind of be confident that it'll run. Yeah, so this just shows a diagram of how kind of dev test might work. So on the left, there's developers using Docker to build Windows and Linux Docker images that they test. They can push that to a Docker trusted registry or to Docker Hub also. Then QA can check out those or pull those images from the registry, test them, make sure they're good, and then those can be shipped to production and deployed on production systems. And here's another one, like kind of trying to take apps that you're maintaining and like right now where you have all these problems ensuring consistency of developer and runtime environments, you can take those apps, put them into containers, and that just gives you much greater flexibility to deploy them, because you don't have to worry about whether you can get all those dependencies installed on the environment where they need to run. As long as Docker Engine is there, you can be confident that the app will run. All right. Yeah, so some of you may know that we have a product called Docker Data Center. So Docker Data Center is it's a system for managing building, running, and shipping containerized apps. So it gives you a GUI, and it gives you kind of user management and role-based access control that ties into your Active Directory. So that you can manage access to apps, images, and so on. That's already a great product for managing Linux containerized workloads, and we're working very hard to also enable that on Windows, and we'll be demoing that in Q4 this year. And yeah, we're working very hard to also make that work for Windows. Yeah. And yeah, and the neat thing, once we get it working on both Linux and Windows, then Docker Data Center can be that kind of one pane of glass that lets you administrate and monitor both your Linux-based and Windows-based Dockerized applications. Yeah. Just give you to drill into what Docker Data Center is in slightly more detail. There's kind of two main components. There's the Docker Trusted Registry, which is a kind of hardened version of the Docker registry that you can install on-prem or in the cloud. And then that runs alongside the Docker Universal Control Plane, which is the graphical UI for managing both images and containerized apps running on top of a set of either or both Windows and Linux compute nodes. Yeah, and as I mentioned in the introduction, with the launch of Windows Server 2016, the partnership that we have with Microsoft means that if you're getting support for Windows Server 2016, you also get support for Docker CS Engine. Yep, you can get help from Microsoft with your Docker workloads, and they can escalate to us, so we can also help you if Microsoft gets stuck. And that comes with all versions of Windows Server 2016, Data Center Standard and Essentials. All right, I'll do some demos now. So let's do that. All right, so as I mentioned, there are a couple of ways that you can get started developing Windows containers. So if you're on Windows 10 and you have the Anniversary Edition update, by far the easiest is to install Docker for Windows. And that sets you up, and if you install the beta, if you use the beta channel, then that gets you access to both a Linux container development environment and a Windows container development environment. So you can see I have Docker for Windows running down here, and we now have a toggle that lets you switch between Linux and Windows container development. Yeah, so that's the fastest way to get started. So if you plan to do a lot of Windows container work, it might be worth it to set up Hyper-V VM, which is actually what I've done here. So I run a Windows Server 2016 VM on my machine. And then you can see if I do Docker version, my client is on Windows, not surprisingly. That's the CLI, but also the engine is running on Windows. And so in this case, it's running inside of that Windows Server 2016 VM. And so the way I set it up is that I basically just make the Docker Engine API inside of the VM available to my Windows 10 client. And then I set the Docker host to point to that Engine API, and then I can use the Docker Engine from Windows 10. I'll go into more details about the installation options later. But so you can see I can do Docker images. It's not very nicely formatted, but you can see the two images the two base layers. There's Microsoft Nano Server, which is about 800 megabytes unpacked. And then there's Windows Server Core, which is slightly larger. So to run my first container, I can do docker run -ti Microsoft Nano Server PowerShell. And that'll then start up a Nano Server container. You can see it starts up pretty quickly, and now it's ready. I can do dir. So you can see this is kind of a clean Windows install running in a containerized environment. So for example, if I were to write a file in here into a text file, so now I have this file here. Then I'm going to go to I'm going to open a different console window, and I'm going to run another Nano Server container, and do dir. And you can see there's no test file inside this one, right? So running multiple containers on Windows has the same semantics as on Linux. They run fully isolated environments. The file system is isolated, the registry is isolated, and the process context is isolated. So if I do get process, I only see the processes running inside of this container. Yeah, so this is running inside of a nano server. So remember that that's the kind of a minimal version of Linux. So just to give you an idea of how it's smaller, we can take a look at how much stuff is inside of System32. Sorry. Good job. So this will count out the number of files in the System32 directories. You can see in nano server is 522. So I'm now going to start another console window, and then I'm going to start a Windows Server core-based container. So remember that that's kind of the base layer, the kind of more standard Windows base layer. Windows Server core. Oops. Set my Docker host. So that'll start a container based off of Windows Server core. Hopefully. Yep. There we go. And then I'll just run the same command inside of here. So I'll do get child item Windows System32. So that's 1946 compared to 522 in Nano Server. So just to give you an idea of how Nano Servers is kind of pared down, minimal version of Windows with much less stuff in it. All right, I'm going to exit these guys. Yeah, actually I'm just going to start up another one again, just to give you an idea of how. So now I'm back inside of a Nano Server container. Here I'm on the host system, so I can use all the normal Docker commands that you know and love, like Docker images, Docker PS. You can see this is the Nano Server container running in the other window. I can Docker exec into it if I want. So do Docker exec gi. Sure. And now I have two shells inside of this guy. So if I write a file, and do dir in the other window, the file showed up. So two shells inside of the same container. Anyway, that's just a small party trick. All right, so that showed just the basics of running containers from base images, the Nano Server and Windows Server core base images. Like another important aspect is how do you build container images, and it's exactly the same as on Linux. So you write Docker files, and what I have here is a Docker file that builds an extremely simple Windows container. So you can see they use the same from instruction, in this case just start from Microsoft Nano Server, and they just set the command to execute when this container is run. So I can do Docker build, let's call it hi. So I built my container, and then I can run this, and it prints hello world, hopefully. So that spun up a container, printed standard out, and then exits it. Exactly the same as on Linux. All right. The final thing I wanted to show is a more complicated demo that shows running kind of a multi-container app with Docker Compose. So Docker Compose is a development tool that we have for running kind of more complex apps that require spinning up multiple containers, hooking up all the networking to make the app run. So I have that here. The app is called Music Store, and it's basically the ASP.NET team's sample app for demoing ASP.NET Core. So in preparation for the launch, there's a guy at Microsoft who worked on this, and I also spent a lot of time on it. But we basically just took that sample app, which is just supposed to run on a normal Windows install in user mode, and then we made it run inside of Windows containers. So while it took a while to get working, the outcome is fairly simple actually, and hopefully it'll be simple to set up in the future for other people. But we added a Docker file and then a Docker Compose file. So you can start by looking at the Docker file. So this is more complex than the one that I showed earlier. So you can see we start from Microsoft.NET. So this is one of the base image, the images that Microsoft publishes on Docker Hub. And so this is a base image based on Windows Server Core, and it then has .NET Core installed inside of it. Then you can see I set the shell. So this is actually a new instruction that we added to the Dockerfile syntax for Windows. So kind of funnily on Windows, the default shell is cmd.exe. So that's basically the shell from MS-DOS, more or less, in the late 80s. So with the shell instruction, there's a way for you to say, hey, when building this Dockerfile, I want to use PowerShell for the rest of the instructions in this file, which makes it way less verbose and awkward. So I set the shell to PowerShell. Then I start adding in, or I create a directory, and I set the working directory to be music store. Then I start adding in the project.json. So if you're more familiar with NPM, that's kind of like requirements.txt or the gem file with Ruby, like it has all the packages required to run the app. Then I run .NET Restore, which is like bundle install or whatever. So that pulls down all the NuGet packages. Finally, I add in the rest of the source code, and then I do a .NET build of the music store app, and then the app is kind of ready. So finally, I just tell what port is this guy going to listen to, and then the CMD instruction is .NET run. Yeah, so that's the Docker file. So that basically builds the kind of application container with my ASP.NET web application based on .NET, the .NET base image. Then the other file we added was a Docker Compose file. So if you're not familiar with Docker Compose, it's a way to specify how a set of containers are supposed to start up and be hooked together so that you can debug them in concert. So it defines two services. There's a DB service, so that's the kind of back-end database. And in this case, it's just based off of an image. So this is another image that Microsoft publishes on Docker Hub. It's Microsoft SQL Server 2016 Express. So that's going to be my backend database, and I make port 1433 available so I can see what's going on in the database. Then the other service is the web service, so that's my ASP.NET web app, and you can see I tell Compose to build from the Docker file that I just showed you. And then I set up some environment, and I set up the port where the app is going to be running. So with those two files, you can see I have them here, the Docker file and the Docker Compose file. I can do Docker Compose build. So you can see I run Docker Compose build. So that'll build my app, and you can see Docker Compose sees, okay, the DB is just an image, so I'm not going to be building that. And then it builds the web container. And I already built this before the webinar, so it's just using the cache, so the build was very fast. But you can see this is Docker just following that recipe in the Docker file to build the container image. All right, so with that build, I can do Docker Compose up like this. So you can see I run Docker Compose, and I specify the Docker Compose file, and then I use the up command, and I've force recreating the containers. It's just a detail to show you how it's working. So that'll create the DB container and the web container, and then it hooks up the networking. so that the web container can talk to the SQL Server container. And hopefully that should be coming up in a couple of seconds. Let's see. Yep. So the app is up now, and I can hopefully open it in the browser. Should be loading. And really, the beauty of this is that I can now run this app. Like I don't even have to install SQL Server in this system. I don't have to install this particular version of .NET that's required. It's all of that complexity is just maintained inside of the Docker containers. And you can see the app's running. It's just a simple CRUD app that shows off ASP.NET MVC. And just to give you an idea of how it's working. So I'm running a SQL Server Management Studio. So that's running on my Windows 10 client, but I can connect to the connect to the SQL Server running inside of the container, like this. And the music stored database is there, and you can see all the tables that were created. Yeah. So yeah, that was just to give you an idea of like how all this stuff also works really well on Windows. And yeah, actually the SQL Server part was like the first time so I built some of the first SQL Server based images before Microsoft started publishing them, and it was just it was so great to get that running. Like I don't know if any of you have ever spent time installing SQL Server, but it like takes a long time, and it's pretty finicky. And if somebody then messes up the environment, then you have to spend a whole bunch of time debugging it and figuring it out. So the first time I got a SQL Server image going, I just sat there spinning up SQL Server instances, as you can see I'm doing now. And it takes us about a second, but then you have a fully self-contained, pristine SQL Server instance running, and I could log into one of those and load up, and my colleagues working on one running beside it would not be affected. So just really neat. You can see in Docker PS, and there's three brand new SQL Server Express instances running side by side. Yeah, I think that's all I had for the demo actually. So let's just get back to the presentation. Yeah, I just wanted to. Oh yeah, so this is how you can get started with Windows containers. So as mentioned, there's a couple of options. If you're on Windows 10 with the Anniversary Edition update, then the simplest option is just to install Docker for Windows and choose the public beta channel. That'll set up Windows Docker daemon also. If you don't want to do that, you can get a Windows Server 2016 ISO and just install it in a VM using Hyper-V or VirtualBox or VMware, whatever makes you happy. And as I mentioned, that's a free 180-day trial of Windows Server 2016, so you don't have to pay for anything. You can also use Azure. So Windows Server went GA yesterday, and with the GA, it's now available on Azure too. So that's a super easy way to get started. If you're on Mac OS or Linux or an older Windows version, then again, just get a hold of the Windows Server 2016 ISO, and then you can set it up in VirtualBox and VMware. Once you have Windows Server 2016, the install of Docker Engine is very simple. It's 2 PowerShell commands. You install a module and then a package that sets up the Docker Engine. If you want kind of slightly more elaborate instructions, I wrote a blog post a couple of weeks ago, and the link is here. But yeah, just go to the Docker blog and scroll back a couple of pages. Then there's a bunch of blog posts from the launch 2 weeks ago that goes through both getting set up, how all the stuff works, like the stuff I covered earlier, and there's also a blog post detailing the commercial partnership that we have with Microsoft. Yeah, just to kind of zoom out a little bit from the Windows container stuff, we're doing a bunch of, if you're a Microsoft technologist, Docker is doing a bunch of other stuff with Microsoft. So we're building something called Docker for Azure, which is still in private beta. But it's basically a very simple way to set up Docker 1.12 with swarm mode on Azure. So it's Linux only at the moment, but we'll be adding Windows support later. And then the neat thing is that it integrates tightly with Azure load balancing, so that you just get a really functional Docker install, scalable Docker install on Azure right out of the gate. So if you want to try that out, go to beta.docker.com and sign up, or just ping me, and I'll get you into the beta. Then we also maintain a set. If you're interested in Docker Data Center, then we have some Azure ARM templates that set up Docker Data Center and Docker Trusted Registry on Azure. And those are already in the Azure Marketplace, so you can go try them out. In addition to that, I work a lot with the .NET team, both the .NET Core team, but also the full .NET team, to make sure that they get great images, both Windows-based and Linux-based, into Docker Hub. And I work with the SQL Server guys. They're very, very excited about Docker, and they, as you saw, they already have a couple of Windows-based images. And actually, if you get into the Microsoft private beta for SQL Server on Linux, one of the ways that they let you try out SQL Server on Linux is in a Docker Linux container. And yeah, it's just really neat. Works super well. And finally, we work with the Visual Studio team, who are building great tools and plugins for Visual Studio Code and the full Visual Studio to help you build containerized apps. Yep. So if you're interested in this technology, go to docker.com/Microsoft or check out some of the blog posts that we wrote about this stuff when for the launch 2 weeks ago. And to try Windows Server 2016, this, as I mentioned, there's a free download. It's pretty easy to set up. And there's also a blog post that I published on how to get to running your first Windows Server container, or you can just start on Azure. Then there's I just want to give a shout out to people in the Docker Captains community who are working on this Windows container stuff. So there's Alex Ellis, there's Elton Stoneman, and Stefan Scherer. They're all doing great work experimenting with Windows containers and kind of building new base images and showing what can be done with technology. So if you're interested, go follow their work. And if you build something great, please tweet at me and at Docker. I'd love to take a look. And then finally, we have another webinar on the 25th, where we will be showing a tool that we call Image to Docker. So it's a way to take a Hyper-V VM image, and then basically what the tool does is it mounts the image, and then it kind of looks through it to see what software is installed and how what websites are set up in IIS and stuff like that, and then it generates a Docker file to you for you. So it's a good way to, if you find kind of authoring Docker files a bit intimidating, this tool is a great way to get started, and based off of a VM that you already have. Yeah, so that was it. Thanks for joining, and I'm very happy to answer questions. Let's go back to the first slide. So you have my contact info. But yeah.
Well, we have quite a few questions. Thank you everyone who's putting them through.
Okay, so Robin asks whether it's possible to push images to DTR running on Ubuntu. So yes, that's possible. So both DTR and Docker Hub support both Windows and Linux images side by side. And there's even kind of what we call multi-arc support, which means that you can, for the same tag, you can have both Windows and Linux variants. So Google, Docker, multi-arc. I wrote a blog post about this in the spring, and that kind of covers all that stuff. So I don't think DTR. To the second part of Rob's question, I don't think DTR runs on Windows just yet, but it's one of the things that we're working on. Okay, how do you update? Jan asks, how do you update Windows containers? So there's kind of two ways you can go about that. Our recommendation is to use the Linux methodology, which is basically, so every time there's going to be a Windows update, Microsoft will publish a new version of the base layers, like Windows Server Core and Nano Server. So I think the best option is really to pull those and then rebuild your container on top of the updated base layer, and then update it, because that kind of gets you the whole paradigm of immutable infrastructure. So that you don't have these pet containers which have accreted layers of updates that are not really tracked in the build. So that's I think our recommendation. Like get the updated base layer and rebuild your container. But you can actually also run Windows Update inside of an existing container image, and then you can commit the change. So you just kind of get the Windows Update as an additional layer on top of the other layers that were built when you built the app image. So both of those should work. Tom asks if there's a GUI for this. So by default, the way you can do this is using the Docker CLI, which works in any shell, or you can use the PowerShell commandlets that I mentioned that Microsoft has built. And then for GUIs, we do have a GUI called Kitematic that shows some of the stuff that's going on with your Docker engine. And then the other option is to get Docker Data Center, which is the full management GUI that you can use to manage containers. Can you have, okay, so Sudhakar asks if you can have two .NET frameworks running side by side in a single Windows container. So if you can install them side by side on Windows normally, then you can also install them side by side in a Windows container. But it's just gonna be like a fairly large container. So I think I'd recommend if you have you can do that, but I'd recommend splitting out the app so that you have the .NET 4.0 part of your app in one container and the .NET 4.5 part of your app in a different container. But like fundamentally, if you can make them run side by side outside of a container, they'll also run side by side inside of a container. Please, so James asks, please elaborate more on MSI support for Docker on Windows Server 2016. So MSI support, so MSI is kind of the way programs are typically packaged for installation on Windows. So when you write, so I'm guessing the question is about like how do you use MSI installers and Docker files? And basically what you have to do when you author the Docker file is to invoke the MSI installer in like a headless mode, so that you can install the software without having to click to a GUI. And there's a bunch of examples of how to do that. So yeah, check out some of the sample Windows Docker files that are already there, like the ones that we built for Golang and MongoDB, and also for SQL Server, actually. You basically have, another good resource for this is actually Chocolatey. So Chocolatey is a kind of package management, third-party package management system for Windows, and they spend a bunch of time trying to automate the installation of software, also MSI-based software on Windows. So their scripts is a good resource for figuring out how to run all sorts of weird MSI installers in a headless manner from inside of a Docker file. Okay, so Damien asks, will RDP work for Windows Nano and Windows Server Core images somehow? The answer is no. It's not like the RDP daemon is just not running inside of the containers. So right now it's focused on kind of server-side apps that can run without a GUI. Having said that, in early tech previews of Windows Server 2016, IDP actually worked from inside of containers, so possibly this is something that Microsoft might look at re-enabling later. But for now, it's focused on server-side apps that do not require GUI or require remote desktoping into containers.
Thank you. I think that concludes the Q&A session. There were a few questions that were repeated, whether or not folks will be getting the slide deck. We will look to put the slide deck in SlideShare and posting it on the docker.com/Microsoft page. Also, there's some folks who would like to register for the Image to Docker tool webinar that we're hosting on October 25th. You can register for that on docker.com in the resources page. You'll see webinars, and you can it'll also be posted on the docker.com/Microsoft page for you to register. And we'll follow up with everyone on the call with the recording of the webinar that you attended today, as well as some additional information on the follow-up webinar. So thank you, Michael. Thank you, everyone. Thank you, everyone, for attending, and have a great day.